Today's notes are going to be on finding inverses, proving that they are indeed inverses, and verify by graphing. An inverse can be written as f to the negative 1 of x. So when you see f to the negative first power, that stands for the inverse of a function. Okay, so f of negative 1 of x, it means inverse. To find the inverse, what we're going to do is we're going to switch x and y, and then we're going to solve for y. So the process is pretty simple in the directions, where I'm just switching x and y and solving for y. Now we are going to remember that when you see f of x, that's the same thing as y, so don't let that confuse you. Then we're going to prove that they're inverses of one another. And the way we're going to do that is we're going to do f of f inverse of x. We're going to use a composition of functions, what we did in last section notes. And when we do f of f inverse of x, our answer needs to be x. And if it is, then I have proved that what I found from the original function and the inverse are indeed inverses. And lastly, we're going to graph. And when we graph these functions, they're going to reflect over the line y equals x. Right? If you see them, the reflection is actually over the line y equals x, then you're doing it correctly. All right, so you're going to go ahead and make sure you have your graphing calculator with you. I'm not going to be able to show that on the video, but I'm going to go ahead and tell you to graph, and I want you to make sure that you sketch down what you see on your calculator. So let's do problem number 1. It says examples, find the inverse, prove they are inverses, and verify by graphing. So number 1 is f of x equals 3x minus 4. All right, so for part A, when I find the inverse, what you may want to do is f of x is the same thing as y. So I'm going to say y equals 3x minus 4. That's what my original function is, right? To find the inverse, what we have to do is switch x and y and solve for y. So what I'm going to do is I'm going to say wherever I had a y, I'm going to place an x, and wherever I had an x, I'm going to place a y. And now I'm going to solve for y after I switched. Okay, so I just switch x and y. To solve for y, I would add 4. X plus 4 equals 3y, and to solve for y, I would divide by 3. So I get y equals x plus 4 all over 3. Now, so that is my inverse function. Let me scroll down a tiny bit, see if I have some room. All right, good. What I would actually like you to do, that is my inverse function. I would love for you to write your final answer because you have a y equals. To make it more obvious to the reader that that is indeed your inverse, I'd like you to make your last step and say f inverse of x is equal to x plus 4 over 3. So that way I know this is the inverse versus this being the original function. Okay? So end your problem with f inverse of x equals. Now to prove it, what I have to do is I have to do the composition of function of f inverse of x, and that must be equal to x. If it's not equal to x, then those are not inverses of one another. It seems confusing, but it's really not bad. When we do composition of functions, we work from inside out. So the inside says f inverse of x. So what I'm going to do is, in place of f inverse of x, I'm going to put in what I had in green. Okay, what I solved for the inverse was x plus 4 over 3. All right? I'm still wondering if this is equal to x. So what I'm going to do is composition of functions. You work from the inside out. Now I'm going to look at the f function, so the original function, and I'm going to plug this in every place I see an x. So instead of an x, I'm going to plug in my inverse. So there's my original function. Instead of 3x minus 4, I'm going to do 3 times my inverse minus 4. And I'm asking if that's equal to x. Well, what's going to happen typically is things are nicely going to cancel out. Like if you look here, 3 and 3 would cancel. I would have x plus 4 minus 4. Well, x plus 4 minus 4, and the 4's will wind up canceling, and I get x equals x. So I've just proved now that x plus 4 over 3 is indeed the inverse of y equals y equals 3x minus 4. All right, the last thing we're going to do is graph. So I want you to go ahead and just sketch an xy axis. I want you to go to y equals on your calculator. And what I'm going to do is my y1, I'm going to put my original function, which was 3x minus 4. Okay, so go ahead, take your calculator, plug in 3x minus 4 on your y1. Then on your y2, what I want you to plug in is the inverse function. So I'm going to plug in. Now be careful when you plug this in the calculator. You need to put the numerator in parentheses. So it's x plus 4 in parentheses, then divide it by 3. All right, so x plus 4 in parentheses, make sure that's in parentheses, divide it by 3. All right. Make sure you do zoom 6 to start. to make sure that you're on a standard window. And what we're going to see is we're going to see two different graphs, all right? The first one that comes up is obviously our initial function, or our function, and then the second one is going to be our inverse. What I'm going to show you is y equals x. This line has a y-intercept of 0 and a slope of up 1 over 1. So y equals x is this line right here. My graphs need to reflect over that line, or I have not found inverse functions. Now, if I kind of go back and look at my graph, my first graph looks like, whoops, I don't know where we just went. There we go. My first graph is going to be, let's see, kind of here and up. And then my second graph is going to be here and across. Right? Now, if you look at your calculator and kind of for my sketch, these graphs are indeed inverses, meaning this is my first function, this is my inverse function, which I want you to label those on your graph. Those do indeed reflect over the line y equals x, meaning a point here, if I reflected it, would go over here. It just is another way to prove that those are indeed inverses one another. All right, let's go ahead and look at number, I'm just going to erase this part. Let's go ahead and look at number 2. My original function is f of x equals x plus 4 squared. So what I'm going to do is I'm going to go ahead and I'm going to write y instead of f of x so that doesn't confuse you guys. And that's my original function. To find the inverse, I switch x and y and solve for y. So I'm going to switch x, switch y, and then at this point I'm solving for y. All right? So if I solve for y, this goes back to like 2 sections ago. If I want to solve for y in something squared, I'm going to take the square root of both sides. All right? But be careful, when you take the square root, it's going to be plus or minus. You have 2 answers there that you can get. Is equal to, the square root squared is just going to be y plus 4. So if I solve for y, I have plus or minus root x, and then minus 4 is on the outside of the radical. So again, write your final answer as, hey, that's my inverse, so f inverse of x is equal to plus or minus root x, and then minus 4 on the side. Okay, so there's my inverse. To prove that, again, we have to do f of f inverse of x, and see, is that equal to x? All right, so what I'm going to do is I'm going to say the inverse function is what I had here. So I'm going to plug in here. I'm just going to go ahead and do the, actually we can do plus and minus. Plus and minus root x minus 4. All right, that was my inverse function. I work from inside out for my composition. So I'm writing down my inverse. Now I'm going to take my inverse and plug that in any place I see an x into my original function. So f of x means I'm going to take my original function and plug it in there. So instead of x plus 4, I have plus or minus root x minus 4. Right? That was what my inverse is. I also have to add 4, and then I'm going to square that. Well, if you look closely, the 4's right away cancel. If I have plus or minus root x, if I square that, whether it's positive or negative, that's still going to equal x. So I just have proved that f inverse of x is plus or minus root x minus 4. Right? When I go to graph this, you're going to do the same thing that you did in the first problem. I'm going to make an xy axis. What I would typically do is draw the line y equals x first, because that's where my graph's going to flip over. So on my y1, you're going to put in your original function. So in your y1, you're going to put parentheses x plus 4 squared. And your y2, you're going to put your inverse. Now, with your y2, I can't put plus or minus x in one y equation. So what I want you to do is you're going to put the square root of x, make sure you close those parentheses, and then minus 4. And then in your y3, because I can do positive square root of x minus 4 or negative, I need to put negative, then square root of x minus 4. All right, so make sure for this one it's a little bit different because you have to do 3 things. Your original, your y1 is just parentheses x plus 4 squared. Your y2 is square root of x, close the parentheses minus 4. And then your y3 is negative square root of x, close your parentheses minus 4. All right, and what you're going to see is we're going to wind up getting 2 parabolas. Okay, my original function kind of looks like this. Okay, and then my inverse function is going to look like this. Now, please make sure that you're doing this on your own on your calculator. Check my graphs with your graphs. If you need to press pause and do that, make sure you're doing that, because it's going to be very confusing if we're asking you to graph and you haven't practiced that. All right, let's move to number 3. So starting on number 3, let's find the inverse. So this is really like a y. So my first step is going to be to switch that to an x, and then I'm going to switch my x into a y. If I want to solve for y, this is the cube root. So if I have a cube root, the way I get rid of a cube root is by cubing both sides. I have to cube the left side and the right side. So x to the third equals, these cancel, I get y plus 2. If I'm solving for y, I just subtract the 2 over. And I want you to write your final answer as f inverse of x is x cubed minus 2. So there's my inverse. To prove it, we're going to do f of f inverse of x and see if that really is x. And if it is, then I've proved that those two things are inverses. The way you start again is plug in what you just got for your inverse. I'm saying instead of my inverse, I'm doing x cubed minus 2. All right. I'm going to take that, and wherever I saw an x in my original function, instead of a plain old x, I'm going to put x cubed minus 2. So I'm going to say cube root. Instead of an x, I now have x cubed minus 2. In my original problem, I still had a plus 2. If you look closely, those will cancel right away, and the cube root of x cubed is x, so those indeed are inverses of one another. All right. For your graph, go ahead and draw a xy axis. I would go ahead and put in your y equals x line. All right. In your y1, you're putting the cube root of x plus 2. If you don't remember, go to your y1, go to your graphing calculator. Your cube root, you press math, and it's number 4. Okay, math number 4 will get you the cube root. Math 4. So do the cube root of x plus 2, all in parentheses. And then my y2, I'm going to go ahead and plug in x cubed minus 3. Excuse me, x cubed minus 2. So x raised to the third minus 2. All right. So my original graph, I guess I'll do these in red. My original graph looks like this. And then my inverse graph looks like this. Okay. So what you want to do again is make sure you're labeling f of x and f inverse of x. Okay. So I've proved that they're inverses algebraically, I've proved it graphically, and I found them algebraically. All right, last one. Same sort of thing. If you want, go ahead and try to do that one on your own. Find the inverse, prove it. And I'm going to help you with graphing because there's going to be something that happens when we graph. We're going to have to create some restrictions here. Okay? So, finding the inverse, instead of this being y, I'm going to switch x and y. I'm going to solve for y. The way I'm going to solve for y is by squaring both sides, right? Because if I want to solve for y and it's square rooted, square both sides. And then I'm just going to subtract 4. I'm going to write my final answer as f inverse of x is equal to x squared minus 4. There's my inverse. Here's my original. Let's do f of f inverse of x. And let's see if that composition of functions is equal to x. If it is, I've proved that the answer algebraically, those are inverse functions of one another. So I'm going to take f of my inverse, meaning what did I just solve for? I'm taking this function, and whatever I got from my inverse function, I'm plugging that in for the x in my original. So instead of square root of x plus 4, instead of my x, I'm going to have x squared minus 4. Well, 4's cancel. Squared x squared is x. So I've just proved that those are inverses. All right. Lastly, we're going to go ahead and graph this. On your y1, you're going to put in square root of x plus 4. In your y2, you're going to put in x squared minus 4. And this is the one I really need to talk about. All right, so please be careful on this graph. I need you to put that in your graph and see what happens originally and what we're going to have to do to restrict that. So square root of x plus 4. Okay, if I go ahead and actually graph that one first, just because I want you to do that. For this problem, hold on, let me put in y equals x. So if I put in the original function, so this is my f of x, that's going to be square root of x plus 4. All right, go ahead and do that first. Now I want you to go back to your y2 and enter in x squared minus 4. I want you to press graph. And what's going to happen is you're going to have something that looks like this. Let me do it in green. Don't draw this yet. Okay, but your graph's going to look something like this. Now, obviously, that is not a reflection because my red line, the reflection of that should be this line, okay? But this part is kind of extra, right? And the reason why is if my original function just has square root of x plus 4, it's just the positive root, okay? So I have to restrict my answer. I'm going to go back and erase the green, okay? I cannot draw that whole parabola. I can only draw the part of the parabola that's actually going to be the reflection of my original function. So the only thing I'm actually going to draw is this part because that's the reflection of my original. Okay, so please be careful that sometimes you're going to have to restrict your graph, right? You're going to have to look at what the original was and then restrict your answer, your inverse function, to only being the reflection of my original. Okay, again, if you want to practice some more of these or go back and get your calculator and make sure you can graph these correctly, and we'll see you guys tomorrow.